In this part of the data structure course related to functions and argument passing, we will cover parameter passing by value and parameter passing by pointers. Suppose that we desire to swap the contents of two integer variables. Consider the following function. Swap is the name of the function. We have two parameters, integer v1 and integer v2. There is no return value. Inside the swap function, we are declaring a temporary variable, temp. Its value is assigned as v2. And then we are setting the value of v2 to v1 and then v1 to temp. So by this code, we are intending to interchange the content of the parameters v1 and v2. In the main part, we are declaring two integer variables I and j, which are initialized to 10 and 20. There is a cout statement saying that before swap, this is for tab operation, /t is tab, and then it is written I and column. And then the value of I is outputted. Then comes another tab, and then j column, and then the value of j is sent to output device. This is for the new line. After the output statement, we have a call to the swap function. We are trying to swap the content of I and j. So this function is called. And then there is another output statement saying after swap, there is a tab here, I column, the value of I, and then another tab and j, the value of j, and new line. So before the swap and after the swap, we want to see what is the value of I and j. When executed, the result is not as we desired, but it is before swap, I is 10 as initialized and j is 20. After swap, we are desiring I to be 20 and j to be 10. The values are to be swapped, but we notice that they are remaining the same. The value of I is still 10 and also the value of j is 20. There are two alternatives to solve the problem. The first alternative is to use pointers as parameters. pswap is the name of the function. Here we have two integer pointer variables, v1 and v2. This is to show that this is a pointer to an integer. And similar for v2. We are declaring a variable temp, and it is initialized by the value pointed by the pointer v2. Here in the declaration, this star means pointer. However, here there is an assignment to the variable temp, which is declared here. Here, it is not declaration for v2, so v2 is a pointer. This star means that the item pointed by v2. So whatever the value of the item is stored into temp. Because v2 is a pointer to an integer, the value stored in the location pointed by v2 is an integer, and that integer is loaded into temp. And here, the item pointed by v2 is set by the value of the item pointed by v1. And then we are setting the value of the item pointed by v1 as temp. This is for the swap operation. In the main part, we are calling the function pswap, this one, because these are pointers. We are sending the address of the item I and address of the item j. Send address of I and j as parameters. So these addresses are to be loaded to the pointers given as parameters. When executed, we will have before swap I is 10, j is 20, and after the swap operation, I becomes 20 and j is 10. So the values are swapped as we desired. The second alternative is to use reference. The name of the function is rswap. We have two parameters. They are integer references named v1 and v2. There is a declaration for temp. It is initialized by v2. v2 is assigned value v1. v1 is assigned value temp. In the main part, we have a call to rswap. I and j are the parameters. Notice that I is corresponding to the first parameter here. The parameter is a reference, so whenever appears v1 in the code, it means that it is same as the variable I given here. J is corresponding to the second parameter, which is a reference to j. So the value of j is loaded to temp. This means that j is assigned value as I. Whatever the value of I is loaded to j here, because these are references to j and I. Then v1 is set as temp. Because v1 is a reference to I, the value of I is set as temp. When compiled and executed, we will have before swap I is 10 and j is 20. After swap, I becomes 20 and j is 10 as we desired. They are swapped. However, if it is declared as the name of the function is cr swap now, just before the declaration of the integer references, we have constants here. The rest is the same with the previous code, only the name of the function is updated here. Then, when executed, we will have before swap I 10 j 20, and notice that after swap the values of the I and j are the same. So if we use constants here, we are not able to interchange the variable values. To understand better the solutions we have seen, now we examine in detail what are the pointer types and reference types. A pointer variable holds values that are the addresses of objects in memory. Typical uses of pointers are the creation of linked lists and management of objects allocated during execution. For a pointer declaration, here we are declaring integer pointer. After the word integer, we are using this star sign to indicate that this is a pointer. So IP is a integer pointer. Instead of writing this star just after integer int, we can write it after the blank. Again, this is same as the above. This is a pointer, integer pointer declaration. Here we have two integer pointer declarations, integer pointer IP1 and pointer IP2. These are two pointers. However, if it is written in this form, integer star IP1, so this is corresponding to the first one. It's a pointer. However, the second one is an integer. If we write in the form integer IP and pointer IP2, this is declaration of an integer and an integer pointer. If we write long star LP, comma LP2, this is a long integer pointer and a long integer. Float FP star FP2, this one is a floating point number, and the second one is floating point pointer. Now let's declare an integer I, which is initialized with 1024, and then let's create a pointer that points to I. Integer pointer IP assigned value I results in an error. There's a type mismatch because the left hand side is a pointer, integer pointer, and right hand side is an integer. So here, instead of I itself, we use this ampersand to say that this is the address of I. In this case, integer pointer IP is declared and it is initialized with the address of the integer I. I is this one. This is correct. The operator ampersand is referred as address of operator. Now let's create another pointer that also points to I. Integer pointer IP2, it is assigned the value IP in the initialization. This is correct. Right hand side is a pointer, left hand side is a pointer, both are integer pointers. Now IP2 also addresses I. In order to create a pointer that points to IP2, IP2 is a pointer, and we are designed to create another pointer which points to a pointer. In that case, if we write integer pointer IP3 loaded with the address of IP, this results in an error. There is type mismatch because this is address of a pointer and left hand side is a pointer. In order to have a correct syntax, it should be written in the form IP3 is a pointer to a pointer to an integer. And then the address of IP2 can be loaded to IP3. So it's a pointer to a point. Notice that here we are creating integer I initialized to 1024. Then IP is pointer to an integer and it is initialized with the address of I. So IP is a pointer pointing to I. And then we are declaring IP2 is a pointer to an integer and it is initialized with IP. So this value is loaded to IP2. Because of that, this is the address of I. So IP2 has also address of I as value. So IP2 is also pointing to integer I. Then we created IP3, which is a pointer to a pointer, and it is initialized with the address of IP2. So it is pointing to IP2. Now let's consider example here. Integer I, 1024, integer pointer IP, address of I, IP points to I, integer K is IP, results in error. Notice that left hand side is a integer and right hand side is a pointer. Instead of that, we have to write in the form integer K is initialized with the item pointed by IP. Notice that if we are using the star in the declaration, it means that it's pointer. However, if we are using it later after declaration, then it means that this is the item pointed by the pointer. So, because IP is pointing to the integer I, the value of the item is 1024. After this operation, the value of k becomes 1024. In general, here we write the type, then pointer, IP. In that case, IP is a pointer to an integer. This is type declaration for the pointer and initialization. If we write star IP, because this is not a declaration, this is corresponding to the item pointed by IP. And if we are using in the right-hand side of the assignment, again, this is the item pointed by IP. This is not a declaration. If we use IP without star, this is the pointer itself. This is not a declaration, so this is the pointer itself. Again, in the left-hand side of the assignment, this is the pointer itself. Let's declare I as an integer, another integer k, which is initialized with -5. So we have I here, an integer, k, another integer initialized with -5. And then IP is a pointer to an integer initialized with the address of I. IP is containing address of I, so this is a pointer pointing to I. The item pointed by IP assigned value k. So the item pointed by IP is I, and it is assigned value, the value of k. So I becomes -5 after this operation. If we use the item pointed by IP assigned value, absolute value of the item pointed by IP, then the value of the item, this is the item pointed IP, it was -5. After absolute value operation, the value of I will become +5. An integer reserves 4 bytes in the memory. Character is 1 byte and a double is 8 bytes. These sizes depend on the system for which the compiler is written. IP points to an integer that is 4 bytes. If we write IP is assigned value IP +1, the value of the address it contains, the pointer contains, is increased by the size of the object. Because IP is a pointer to an integer, then it is incremented by size of integer, which is equal to 4. Notice that IP was pointing to I. After execution of this statement, IP will become IP +1. That means that it is incremented by size of integer, that is 4. It will point to the next integer, which is k, or whatever here it is. However, some compilers needs it to be written explicitly as IP +1 multiplied by size of integer. Another example, integer ijk, these are integer variables. Integer pointer IP initialized with the address of I. The item pointed by IP is assigned value, the item pointed by IP +2. So this line adds to to I. Because IP has the address of I, it is pointing to I. And that item, the item pointed by IP is I. And it is assigned value, the item pointed by IP, which is I plus 2. So I becomes I plus 2. However, if we write IP assigned value IP plus 2, now it contains IP plus 2 times size of integer. Consider an array having 3 elements. A initialized with values 6, 8, and 10. So here we have 3 entries in the array, which are 6, 8, and 10 initially. Remember that A is a pointer pointing to the starting of the array. If we write A plus 2, this is the item pointed by A. It has the address of A0. When it is incremented by 2, it will point to A2, and then the item there is updated as 7. It is assigned value 7. So the value here is changed to 7. Or if we write A plus 1, the item at that location, so it is the item stored here. Assigned value A2 plus 5. A2 was 7. 7 plus 5, it becomes 12. So here the value in this location becomes 12.